Hello.
Hello, good morning.
Good morning.
How are you this morning, Maris?
I'm good. Kind of tired, but good.
Good.
How are you?
Oh, I'm fine. I think I'm about the same. But no, not too bad.
I have a question. Oh, hi, Holly. Okay. Question.
Of course.
So it's for the temperature and heat that quizzes thing.
Yeah. Cool
Yeah.
short questions.
Yes. I think it's number 2. It's like
The
where you
high
have to
low
type it
in
up.
Kelvin.
Yeah, that one.
Yeah. Okay.
Gotta know how to set that one up, you know?
I got you. So let's see. I got to figure out what's my high and low for that. Come on, Microsoft Word. Get in there. You're getting there. It's there we go. Okay, so it's what is that? Is that my South Dakota one? 49 to 7? Wait, no. That was my Browning, Montana one, the negative
Yeah.
49. Yeah. Okay. I got a stash of questions to ask you all. So let's see. I want boom. That one.
Yes.
Okay, so let's do it. So we want in the beginning in Kelvins. Morning, Michaela.
Hi.
So let's do it. Whiteboard. What do we think? Let's do red for the high and let's do blue for the low. That sounds fun. Okay.
Are you doing number 2?
Yeah. Yeah, for some reason, this is always the one that gets you all, but that's all right. So if we want to do these, the final temperature immediately was negative 49 degrees Celsius. So I can write temperature final. Well, no, this is my blue. Temperature final is negative 49 degrees Celsius. Then, just because we experienced a 56 degrees Celsius change in temperature during that 40 or during that 24-hour period. So if you want to think, if we want our temperature initial first off for this one, then what we need to do is that we need to say immediately, if our final was negative 49 and we change 56 degrees Celsius, what's our initial? So let's think of it this way. This is your final. You have some temperature degrees Celsius, and you went then to negative 49 degrees Celsius. If this entire change, can I do this? Oh, that's bad. You get the idea. Is 56 degrees Celsius, then what's this beginning? What do you need? Why'd I write 7? What do you think? Okay. Here. Let's do it this way. Maybe that's not helping you. Let's write it in a different way. Go away. Maybe I can make it a little bit nicer for you. Let's change to magenta and see what we can do. If I write that my change in temperature is equal to 56 degrees Celsius, and I know that my temperature final is negative 49 degrees Celsius, I want to figure out what my temperature initial is. And if you have this equation, change in temperature equals temperature final minus temperature initial, the same change that we've done since day one, how do I rearrange then for temperature initial?
Change in temperature divided by temperature final.
Is it divided if it's subtracted?
I meant.
You're right. So here's what I'm going to do, is that I'm going to go and I'm going to add temperature initial to both sides first. just because I don't like negative numbers, and that sounds annoying. So I'm going to do change in temperature plus temperature initial is equal to my temperature final. Then if I go and I do it this way, subtract out change in temperature from both sides, then I'm going to go and I'm going to have my temperature initial is equal to my temperature final minus my change in temp. That's basically all I have. Wait, something's funky. Do you see the funkiness here? As we're going and looking. I went, this is the correct equation, but the problem is my temperature final, if theoretically that should more likely be my temperature initial, but my temperature final I wrote as negative 49. Negative 49, I would subtract out 56, and I would have a very, very large negative number. It's going, and this equation is hypothesizing that the temperature rose for it as opposed to fell for it. That's our problem right now. But basically, okay, let's get rid of these, because this is probably confusing more so than what I'm intending. Go away, go away. Okay, think of it this way. What's the weather outside right now? 70, 75? It's pretty nice today. I know it's supposed to get up to like 80. So let's just say 70 for nice, easy math. If I say that during our day, the temperature changes from 70 to, I don't know, let's say 20 degrees Fahrenheit. That is a big, big change. What is that change in temperature? If my temperature high was 70, my temperature low is 20, what's the change?
50.
It's 50, yeah, exactly. So here, our idea is that we have a change of temperature of 56. Our low temperature was negative 49 degrees Celsius, meaning that our high temperature then needs to be negative 49 plus 56. That's the main idea. So if we do negative 49 plus 56, you would go and you would get a temperature initial then of 7 degrees Celsius.
Okay, I have a question.
Yeah.
So I remember like on the video, you know, whenever you showed us like that chart with like each equation.
Mm-hmm.
So like I thought to find it in Kelvin, you just added 273 to like whatever your temperature was. It like
You do.
gave- Oh, wait.
You're absolutely correct. You do. So if I want both of these in Kelvin, I'm just going to go and I'm going to add 273. So this one's 280 Kelvin. This one plus 273. Oh, I don't want to do that in my head. Where's my calculator? Oy. Let's take negative 49 plus 273 equals 224 Kelvin. Oh, boom. So your two answers should be 280 and 224 Kelvin. That's the idea. Changing into Kelvin is like the simplest thing ever. You just add. I mean, it gets annoying whenever you have to start thinking about decimal places and sig figs and stuff like that. But for the most
Okay, I
part,
have another question.
yeah, of course.
Okay, so why did you add, like, where did you get 7 degrees Celsius? Because I thought one of the number, like, instead of 7, I used 56.
Uh-huh. It's from the problem itself. The idea was that 56 is the change in temperature. So if you like read the problem, it says experience a temperature decrease of 56 degrees Celsius during a 24-hour period. The only way for you to decrease that temperature, I mean, again, if that negative 49 degrees Celsius is your final temperature, and you had a change of temperature of 56 degrees Celsius, then you know that your high temperature is 7 degrees Celsius.
Oh.
Yeah,
Okay.
it's just reading. You read and you skimmed the the question for numbers. You're like, oh, 56, negative 49. Sweet, check, done. Add, and yeah. That's why, Michaela. Just you working quickly. All right, let's get rid of this one because you are all just itty bitty squares right now. There we go. That's better.
So I just submitted my quiz thing, Canvas, and like all of them are wrong. I don't know what I did wrong because like it might be the units or something because I was kind of confused what to do with that.
Yeah, it might be. Let me check real quick. So with your units, I took like the degree symbol. If people like copied and pasted it, I took no degree symbol. Like if you wrote 273F, then I would have counted that. Or some students went and actually like typed out degrees for it. And I was like, oh my gosh, how did I not think of that? And then I put it in so that it counts as that. So there's lots and lots and lots of different like little ones that we can do. But let's see. What did Miss Maris do? Most of the time with this quiz, it's been sig figs like mad. It's been the only thing.
Yeah, I'm not good at those.
Yeah, that's what I'm kind of confused about because like if we started with negative 49 and that's only 2, like if like we got 224 for one of our answers, should I be changing it to 220?
You're adding, Michaela. What's your sig fig rules with adding or subtracting?
You don't?
You go off of decimal points.
Oh.
How many decimal points the original had. Yeah, that sucker, right?
But I still don't know what that means. Like I remember, but like I don't know what I would change it to then.
16. Or it's your sig figs on every single one, Maris.
Yeah. Can you help us?
Of course I can.
Yes.
So let's do it this way. What's a good one? Let's do question 4 because that one has both of them together. So let's see. Let's go back to share screen, whiteboard, clear all. How do I get the chat bubble? Come on. Whiteboard, remote control, more chat. There we go. So I want that problem. So that's your 4th one on the quiz. So we have a 2-year-old girl that was locked outside during winter. And me and my morbid sense, I'm going to use blue, of what it is that her body temperature dropped as low as 14 degrees Celsius. And I want to express this low temperature in kelvins and in degrees Fahrenheit. So I'm just going to write temperature low equals 14 degrees Celsius to start out with. If I want to first figure out the temperature in kelvins, then what I'm going to do is I'm going to take the temperature in degrees Celsius and just add 273. So here, I should just take 14 degrees Celsius plus 273. And that's 287? Yeah. 287 Kelvin. So that's going to be your first just value. And remember, if we're adding, so we need to go off the sig figs based entirely off of these values. And what I mean by that is that this value, our 14, has 0 decimal points, meaning that our answer needs 0 decimal points. We would keep it exactly as 287 Kelvin. Then, if we want our temperature Fahrenheit, let's think. Temperature Fahrenheit is equal, is this the 5/9 or 9/5? I don't have it in front of me. Someone's got to have your work in front of you. Help me out.
Yeah, it's 9/5.
Yeah, so it's the 9/5. All right, so it's the 9/5, and it's the temperature degrees Celsius plus 32. They always flip. Yeah, that's 32.0. Okay, so if we want here, what we want to do first is let's plug in our temperature in degrees Celsius. So 9/5 of 14 degrees Celsius plus 32.0. Then we're just going to collapse it into 9/5 times 32.46. Yep. And still no decimals, so 2 sig figs. Multiply it by 9/5. Oy. So I need 9 divided by 5 times 46. Boom. And I get 82.8. Is that correct? Oh, something's funky. What did we do?
On my work, like I didn't do the parentheses on it. I thought that one was.
It's the parentheses for the Celsius one.
Yeah.
That would explain it. Yeah, more than likely. I was like, no, that's not right. Something's weird because my temperature in Celsius should not be that much higher than my temperature in stinking Fahrenheit. There we go.
Wait, so what did we do wrong? Because like what you just did is what I did.
Of our equation, let's find our actual equation for us. Make sure that we're doing these two equations, Michaela, they are so annoying because one of them has a parentheses and it's subtracted, and the other one has no parentheses and is added. And they're literally just inverses of each other, which is why I never actually go and take the opportunity to memorize them. So, there we go. Our temperature in degrees, here, let me just show you the two differences. If I plug this into the chat, is that going to work for us, or is that going to shoot back something that you don't want? There we go. Okay. So those are our two equations, specifically of the temperature in degrees Fahrenheit, and then here's the temperature in degrees Celsius. That the idea is that if we're trying to find the Fahrenheit, you notice how it's adding 32 and it's not in parentheses. Well, if it's Celsius, it's in parentheses, it's 5 nines, and you're subtracting out the 32. They're always just the opposite of the other. So what we did that, instantly I started thinking, is we added the parentheses around this 32, meaning that we would add it first and then multiply it by 9/5, and you would get the wrong answer. But if we follow the equation here, and just knowing that the temperature Fahrenheit is 9/5 temperature Celsius, then we go and we do 9/5 times 14. Let's see what we get. 9/5 times 14. There we go. 25.2 plus 32. We get 57.2 degrees Fahrenheit. So let's go there. 0.2 degrees Fahrenheit. But here is one of the times where we're multiplying. This 9/5 by itself, this is a given. You don't need to worry about that. But this 46 absolutely is a measurement. This has 2 sig figs, and now we add in our multiplication sig fig rules, meaning we need 2 sig figs in our answer. We drop the 0.2, and our final answer is 57 degrees Fahrenheit. So it's all about sig figs with these, which is, usually where my students go and start complaining at me. But those should be your two values, 287 Kelvin and 57 degrees Fahrenheit. You want to plug those in, Maris? Make sure that we're right.
So on number 3, if I have I think at least I don't have any decimal points. Like one of my values, all my values are 3 numbers. Like will my final answer just be 3 numbers? Because I'm confused what I'm doing wrong.
What are we doing? Did you convert it first into Celsius?
No.
Yeah, there's your, because the temperature Kelvin can only work off the Celsius. That's the only way it works because you have to plug it into Celsius first. So for number 3, you have 116 Fahrenheit for heat stroke. You have to change that 116 Fahrenheit into Celsius and then change that Celsius into Kelvin. It's a double step. Right? Yeah. There we go.
All right, so the other day I was looking at the like notes for quantum theory of light. And
Yes.
it made sense up until like the what does it mean for the atom part, and then I just didn't understand any of it. Like, okay, I have a list of questions, I think. Okay.
Shoot,
So
please.
when you were saying, wait, my notes don't make sense. Okay. Oh, when you were saying like it switches energy levels, what switches energy levels? Like, was it the electrons that switched
The
them?
electrons. That's exactly
Okay, because
right.
I think you said atoms a couple times and I just got confused.
Oh, no, it's always the electrons are the only thing that moves. So if
Okay.
an electron jumps from like an energy level of 1 to an energy level of 3, then it's gained that specific radiation, that amount of energy, and then whenever it falls back down, then it emits that same amount of energy, which is what you perceive as light.
Okay, got it. And okay, that makes more sense. I will edit that in my notes because that makes a lot more
You're
sense.
fine. Quantum theory is always one of those ones. I really do wish that we were able to like, chit chat about it in class. It's always that and particle wave duality are always so like fun. Yeah, you'll get there. But
yeah, I just got there literally just now, and it doesn't make sense. Like, wouldn't it be wouldn't it be easier for the particle to just, I don't know,
yes,
I think it's funny.
yes, logic is thrown out of the window in quantum, Holly. We go off of math and we go off of experiments. That's the idea, which is why it's always so much fun. You doing your problem, Michaela? You trying to figure it out?
I'm trying.
Okay.
Also for number 2 though, that's what I was looking at. I'm not sure which, because my work is kind of like all messed up from, I don't know, but I don't know which one is like temperature low, temperature high.
Really?
Yeah.
Temperature high, temperature low?
Like, is it just like literally whatever number's bigger? I feel like it wouldn't have been that simple.
No. It's based off the originals. Because, as I said, we had that 7 degrees, and then we had that...
Okay, then I got it right. I was just making sure.
Yeah. You should be all right. Right? Yeah. That's all. There we go. I'm having to go. Let's see.
So, like on, I don't know what problem it was, but like we did it wrong because like we used parentheses or whatever.
Mm-hmm.
Like this one, would we use parentheses? Because
For
like
the temperature, yeah, you're finding temperature Celsius.
Okay.
So that's going to be the 5 nines. Yeah. Perfect. There we go. Hey, we got Ellie this morning. Morning. Yeah. Oh, you're all set there. Let's see. How are people doing on the temperature and heat so far? Well, not bad. Definitely not bad. Almost nobody has turned it in, which, makes sense. But
I'm getting a fraction.
for it, you shouldn't get fractions. I mean, you should have your, 9/5 multiplied by your value, but 9/5 even then, Like change it into a decimal. You never, ever, ever want fractions here. They are no good. And of that I promise. Let's see. I'm just running through, seeing how we all done. What are people doing here? This is weird.
I'm kind of confused on number 1 on the electromagnetic wave problems.
So let's see. What do we do? So Holly, with any of those electromagnetic wave problems, let me ask you first, have you solved for the frequency of that or wavelength yet? Because correct me if I'm wrong, but it gives you a wavelength on number 1, correct?
Number 1, I think so, yeah.
Yeah. So how are you going to first solve for that frequency then? Let me ask you. What's the only equation in the entire thing that has both wavelength and frequency in it?
1 second.
You're okay. Just keep on searching.
Velocity equals wavelength times frequency.
Perfect. Now, what's the velocity of that wave? If it's a wave of light, it should always be.
Oh, that's right.
Yeah, there you go.
I forgot which one I forgot what that was, but yeah. Okay.
Yeah. Yep. So it's 3 times 10 to the 8th. As soon as you plug that in for the velocity, solve for your frequency, plug in a new energy, check.
I overthought that. Thank you.
Yeah, it's always that one. Okay. Let's see. How'd everyone do on our waves checkup? I checked it on like Saturday, but we still had a lot of people. And we're still in the process of taking it. Let's see.
Mr. Tate.
Miss Michaela.
So, if I, like, after I turn 5/9 to a decimal, and then am I supposed to be multiplying it by 1/16 and 32, or should I be subtracting 1/16 from 32 and then multiplying 0.55 times 84?
Correct me if I'm. You're going from. Okay, so you went to the 1/16 to Celsius first. Here. Let's do it.
Yeah, I don't.
I was like, wait, what? Oh. All right. What do I want? Let's do orange. I feel like orange is a nice fever color. So if we started out, our temperature in degrees Fahrenheit was 116 degrees Fahrenheit. The first thing that we want to do is that we want to eventually get this into temperature Kelvin. And to get it into temperature Kelvin, first we have to get it into temperature degrees Celsius, and then the temperature in degrees Celsius into temperature Kelvin. It's always just that process. So let's first change our temperature in degrees Fahrenheit into temperature in degrees Celsius. So where's my equation? There we go. If we want a temperature in degrees Celsius, we always make it temperature degrees Celsius is equal to, and it's 5/9 multiplied by the parentheses of temperature of degrees Fahrenheit minus 32.0. That's where we're going to start out. Just saying, though, that if we plug it in, we need 5/9 multiplied by 116 degrees Fahrenheit minus 32. Then we're going to get 5/9 multiplied, head math, 984. All right. Anyone? Marco?
Wait, what are you asking?
It is 84, you jerks. Making me think that, gosh. Oh my gosh. Multiplied by 84. So now let's just do 84 times 5 is 420 divided by 9 is 46.6 repeating. So we get a value of 46.6 repeating. But as always, we got to do our bestest friend, and our bestest friend here, just because we started out with 3 sig figs, you need 3 sig figs. So for this, we are going to say it is 46.7 degrees Celsius. Boom. Then, as soon as we get this, 46.7 degrees Celsius, just add 273, because temperature Kelvin is equal to temperature degrees Celsius plus 273. So we're going to say 46.7 plus 273.
319.7.
Perfect. 319.7 Kelvin. Done. Perfect.
Okay, thank you. Because I was confused, like, if I was supposed to like multiply 5/9 by 116 and 32, if I was supposed to subtract them first to get 84. That's where I didn't know what to do next.
Yeah. Yep. It's always just 84, and then you go and you plug it in, and then it's all pretty. And yeah. No, perfect. 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 Let's see. Yep. And that was good old Willie. I'm just double checking. Yeah, awesome.
So it says that I got 2.5 out of 4, and I just used the same answers that we did together.
So what did you do? Let's go
4
check.
and 2 wrong.
4 and 2. Let's go check. This, and then I need speed grader. Oh, you all should see how you have to go and grade these stinking things on the computer. This is like
I
just
got number 2 wrong because I put K instead of. Oh my god.
it should just be K. Let's see. S R N Noble Neri. There we go. So what'd you do? Question 1? Nope, 1's fine. Good job. Oh, you you flipped the high and low on number 2, Michaela.
Oh
That's why.
my gosh. And how was number 4 wrong? I mean, I probably flipped them too.
You put a space in between your degrees in Fahrenheit. Okay. So no, you're not wrong. Update there. Sold. Yeah, you flipped your high and low. So there's 1, there's 2. I got it. Got it. Update. Check. Congrats. If you press refresh now, you're good.
Oh, okay.
Yeah. Because you got all of your numbers right. It's literally just stupid computer stuff, which is infuriating. So. Good old computer stuff. All right, questions.
Mr. Tate,
Yes, ma'am.
On number 2, it says like it's like halfway right,
What did
but
you?
wrong. I don't know.
You're okay. Let's go check.
I have number 1 wrong too, so I need to do that one.
$50 says it's your sig figs.
It
Do you have 4
probably-
sig figs in it?
No. How do I do that? Do I just add like zeros?
Uh-huh.
Oh.
Is it your sig figs? Yep. Yep, it's your sig figs.
How do I fix it? Do I do like a decimal or something?
Should be 460.0. Yeah.
Oh, why? It's like, but it's like 860, right? Is what you started out with.
860.0, which is 4 sig figs.
0.0? Wait, hold up. I missed that. Oopsie. Oh yeah, it is.
Why isn't that doing it for me? Oh, that's weird.
Bye, Mr. Tate. Thank you.
Of course, Michaela. See ya. Thank you.
Let's try this.
Where'd that number come from? What the heck? Hold up. Let's refresh this. Is it going to? Nope. Well, that's weird. 12 and 1. Yes.
Because I mean, didn't we do number 2 together?
Yeah. No, you have the right answers. No, I plugged in the wrong value for number 2 whenever I first made the quiz.
Oh.
It should be the 280 and 224. You are 100% correct. But I plugged in the wrong value whenever I first made the quiz. And I was like, oh, no. Go away. And now for some reason, it's wanting you to put in the wrong value as the correct. Okay, I've updated it both times.
Okay.
I've saved. Fingers crossed. Okay, saved. Now let's go back. Quizzes. I swear to goodness, this like online grading thing is absolute just monstrosities. Do you know how badly I want you all to turn in a nice piece of paper with all of your work on it? Oh my, you have no idea. Like, I am as old-fashioned as it comes with this kind of stuff. Okay.
Oh, yay, now I'm good. Yay.
Oh, phew. Yay.
Yay.
All right, sweet. Yeah. I just had to press stinking save. If I had pressed save, then I would have been good. Yep. Sweet. All right. Awesome. Awesome. There we go. Okay, so we're getting there. How many people have turned it in? 9. We got 9 out of 67 so far. Let's see. Alex.
Oh, I was looking at, I was doing the notes a couple days ago, and you were talking about microwaves and how a lot of people's parents think that it's more dangerous than it is. And that reminded me of an old friend of mine. Her mom is she's a nice lady. She is, but she's very protective just because of things she does. And apparently, when this girl was like 8, her mom had always said, don't be in the same room whenever I'm doing microwaving. Like, leave the room whenever I microwave.
No.
And so one time when she was like maybe 7 or 8, like her mom started microwaving something in the same room as she was in.
Yes.
And she hit her under the table. So
okay.
I was like, oh my goodness, that's...
Pause. Number 1 is that if you don't know that microwaves aren't going to hurt you, fine. Number 2, why would you think that the table would protect you?
No, she just was scared. She was like,
through object. Like,
she was like, I don't know what to do. My mom's never let me be in the room when I microwave stuff, so she just hid under the table. I was like, oh my gosh, I feel so bad for you. And then her mom was like, no, that probably wasn't necessary, but
I know, like, whenever I go and tell my students, literally you could go and like tape your phone to your head from now until you are the age of 99, and you will never once see adverse effects unless like the lithium battery on your phone blows up. Like, that's it. No, you are not. It drives me up the wall because I'm sure parents are using it as an excuse anyway for like, put your phone away, like don't keep it near your bed and stuff like that. Like, oh, the microwaves are, or you know, the cell signal is going to go and it's going to hurt. Like, no, for goodness sake, no. But
I have always been a little bit skeptical of that. I was like, I saw some things, but I was like, I don't know. I was like, well, I'm not really going to argue with her because that's not really worth it. I was always
can, no, absolutely argue in this day and age. UV, X-ray, gamma are the only three that can interact with you. Unless you have one of those three types, then no. Like everyone with the 5G towers right now, what kind of waves do you think the 5G towers use? It's stinging radio. For God's sake. It's the lowest possible amount of energy. Like,
we didn't even like talk about it. Like you were just like, it's really low. Just like
open up a single science textbook. And so the people that are complaining that 5G is the actual like raw thing, no, they're not going to look up a science textbook anyway. But open it up, go to electromagnetic radiation, see it's radio, and you're fine. Like, no, literally go and hug a stinging 5G tower, and there's going to be zero impact on you.
Yeah, weren't people burning them down because they thought it was because of Corona?
Yes.
Corona? What? How did we get from that to coronavirus?
Everyone knows that it was the stupid broom thing that caused the corona because of witches.
You're right.
It was the witches.
Like, this just physically pains me as a science teacher with the stupidity that I see. Like, just
I think anyone that understands basic waves, that would just hurt their soul.
Just basic science.
I've seen a lot of people get freaked out about stuff or not get freaked out about stuff that they should probably be a little bit more concerned about and have just like completely disregarded science. And it's like, it's okay if you don't know, but like, if you choose to ignore it, my guy, that's not great. I'm gonna get frustrated at you for that one.
Like, I know. Oh goodness. Oh. All right. Well, what do we got? We got 2 minutes before I know. So, do we have any last? I mean, again, I can stay a couple of minutes afterwards. I just most of the time want you all to go like work on other stuff. Yes, because you have other schoolwork that I know is more demanding than me. I'm trying to get you, an apt balance between my amount and like everyone else's. Yeah.
I'm like kind of getting caught up in all my classes, so I'm like, ooh.
I was caught up in all of my classes. Thank God I got out of that. I turned in all my late work finally.
I know. I need to go on a grading spree. After every single weekend, like I get like 40 different assignments. And I'm just like, oh, I mean, it's good. Don't get me wrong, but I'm just, so that's my job for today. It's just great.
Good luck with that.
Thank you. All right. So what do we got? Any final questions for me? We got to have something for me to do.
I do have something. Oh my gosh. Okay. So the only like way I kind of understood what you were talking about and like what was it? When you were talking about microwaves and stuff, is I used to watch a show called Fetch. Okay. It was good and it was science and it was weird and it was great.
Do I need to go and look this up?
Please, it is amazing. It's my childhood in a show. Like, Jesus. Like, I thought it was like so smart for watching it. I was like, oh yeah, I watched Fetch. And everybody's like, what's that? And I was like, get on my level.
I can just imagine little Maris bragging in like the playground, like, I watch Fetch. I'm smart. I'm a cool science girl.
Like literally didn't
I love it.
Like I understood it because like they were like there was this sister of the dog and like the dogs okay, hear me out. And so they were like they had the fetchers, which are the people, the kid contestant people, had to go and track down the sister dog person and who was actually the grandma.
What?
Maris, I think you just made my day.
I'm so confused. I'm intrigued, but I'm confused.
Yeah.
I'll send you guys the link, okay?
Okay.
Oh gosh.
Find it right now.
I think it makes more sense with context because what?
Good. I was like, oh my god, yes. And then it talks about like butterflies and eagles and
What?
Get some bio in.
They all use like because like the eagles and the glasses they can like see, and then the butterflies like UV ray light or something.
Oh, are you talking about like how certain animals can see different colors that we can't see?
Kinda, yeah.
With, like that's very cool. Did you know mantis shrimp can see so many different colors than us? That blows my mind. I wish we had more cone cells in our eyes. That would be so cool.
Mantis shrimp are probably like, not like actually, but like scientifically probably my favorite animal in the world because they can create
They're the coolest
sonic,
animal ever.
like whips with their like hands, and like it literally breaks the speed of sound, and they have the most cones and rods possible out of any animal. Like it's fantastic.
Blows my mind. Like it's so cool because I do art. Like I'm an artist, and just the concept of like colors we can't see is so cool. You know.
Oh, that would be sweet. All right. Anything final besides fetch? Ellie, you think you're okay? Just okay.
I'm just
makes so much more sense now that I know it's electrons and not atoms. So
yeah, like I probably misspeak. Like I got who was it? It was Nora went and sent me an email of it was a clip of me in my actual video saying degrees Kelvin, and she's like, "Hey, I caught you," and I was like, "Oh my god, like go away!" Like so, I misspeak all the time. Like don't.
that's the epitome of like how bored we are. Just like
yeah.
Is that what?
I sent Olivia Rega a text this morning. It was like I'm watching the physics thing from like last week or something with Kelvin and that sub and temperature. And you said one thing like, that is not actually absolute zero. And you said like something and it just made me laugh so much. I'm like, I have to send this to Olivia. And she sends it back. Yeah, he's a giant dork or something like that. And like, yeah, exactly.
About right.
Yeah,
but it makes it nice. I know. I can always go, wait. Gosh. I know. I'm so sad. I can't even tell you all of my like gigantic dork science stories anymore because I'm now cut to like a 20-minute time limit. Because if I go and like talk, that's why the stinking like scientist one with the black body radiation was like 40 minutes long, is because I'm like so excited. Yeah, I know. And Maris is over here being like, oh my God. So
I've kind of become numb to the random weird science stories because you told me so many at school, like during contact and stuff, and I'd just be bored.
I want to share my weird science stories that you are the great grandchildren of, Planck's and like, just.
That's cool.
I was thinking about that. I was like, imagine if one of us become a teacher and we share that fun fact and that just goes on forever.
It's just a continuous chain.
So my teacher's science teacher was my teacher's science teacher was their teacher's science teacher was their assistant the Planck.
I wonder if I could still find. I want to go and like we actually made like an actual like family tree based off of teachers in college with it, and that's like the grandfather or something. Like he's my physics grandfather, your physics great grandfather. Like it's slowly increasing. It's great.
Do you remember that thing that was like 7 degrees from Kevin Bacon? It's like that, but with like Max Planck. There was a thing where it's like there was like an actor and he was in a ton of films and somehow everyone was like 7 people away from that. And I don't know what it was, but yeah, like we would like everyone was big about this thing for like in like a while ago, and that reminded me of that. It's like we're all all of the people in this class are like 7 degrees from Max Planck, which is such a specific thing, but it's true.
Oh gosh, I love it. All right, everyone. Well, I think that's about it for today. I know. But thank you all. Have a great day.
Thursday.
Yeah, see ya. Bye, everyone.
Bye, thank you.
Of course.